Close your eyes for a moment and imagine drifting into sleep while floating through the stars. Milky Way, what if the very lullabies of the universe were hidden inside the mysteries of space? Tonight, you won't just fall asleep. You'll dream among galaxies, walk on planets where sunsets last for hours, and witness secrets written in the fabric of the cosmos. Space isn't just a silent void, it's a symphony of the extraordinary. Did you know there are stars that pulse like heartbeats, sending waves of light across galaxies millions of years away? Or that some planets rain diamonds, sparkling endlessly in skies we may never touch? These aren't science fiction fantasies, these are real, breathtaking truths that scientists have uncovered. Facts that transform the way we see our place in the universe. Picture this: black holes, invisible giants, bending time and swallowing light, as if it were nothing but a fleeting whisper. Imagine galaxies colliding in slow motion, a cosmic dance lasting billions of years, yet so graceful, it feels like poetry in motion. And while all of this happens, Earth spins quietly, cradling us under a blanket of stars. As you let your eyelids grow heavy, you'll discover that space isn't just far away. It's closer than your heartbeat, woven into the oxygen you breathe, the dust in your bones, the very light touching your skin. Tonight, let's wander into the universe, guided not by rockets or ships, but by curiosity, wonder, and imagination. When we look up at the night sky, stars appear as silent twinkles, frozen points of light in the vast black canvas. But what if I told you that those stars aren't silent at all? That, in fact, the universe has been playing a grand symphony since the very beginning of time? Yes, stars actually sing. They don't sing in melodies we hear with our ears, but through vibrations that ripple like music across the cosmos. Each star is like a massive musical instrument, resonating with sound waves deep within its fiery heart. The surface of a star quivers, pulsates, almost like the strings of a violin or the skin of a drum. These waves travel outward, and though we cannot hear them directly in the vacuum of space, scientists have captured their frequencies and transformed them into audible sound. What they discovered is nothing short of breathtaking. Stars humming, stars drumming, stars whispering low, haunting tones that echo through eternity. Imagine a giant star, 1,000 times the size of our sun, rumbling with a bass note so deep it would take hours to complete a single vibration. Picture smaller, younger stars shimmering with high-pitched tones like bells ringing across galaxies. Together, millions of stars create a chorus, a hidden orchestra playing beyond the limits of human hearing. Astronomers call this field asteroseismology, the study of starquakes, and it has revealed secrets about stars that we never thought possible: their age, their density, even their inner structure. Think of it, a star's heartbeat can be measured through its song. The vibrations are clues, codes written in waves of light and energy, telling us where a star is in its life, whether it is still burning bright, nearing its end, or ready to explode in a spectacular supernova. And every one of these sounds, every one of these cosmic notes, travels through the void, across distances so vast our minds can barely comprehend them. So the next time you look up at the sky, remember that it isn't silent. Those stars, those flickering diamonds above, are performing for you. They are singing songs older than humanity, older than Earth itself, songs that will continue long after we are gone. And though you may not hear them with your ears, you can feel them in your imagination, the universe's eternal lullaby, softly echoing among the stars. Imagine a world where the skies above do not weep with raindrops of water, but instead with glistening gems falling endlessly from the heavens. On Neptune and Uranus, this is not a dream, nor a myth spun from fantasy. It is a scientific reality. Deep within these massive ice giants, the unimaginable occurs. The rain is not of clouds and storms as we know them on Earth, but of diamonds cascading through thick, crushing atmospheres. Here's how it happens. The atmospheres of Neptune and Uranus are filled with methane gas. Under the enormous pressure and scorching temperatures found deep below their visible layers, the carbon atoms in methane break apart. These atoms, once free, are pressed together so tightly that they crystallize into diamonds. Imagine trillions upon trillions of tiny diamonds forming in an instant, falling like glittering hailstones through layers of atmosphere thousands of kilometers thick. As they drift downward, some may gather into massive diamond chunks, tumbling through the skies until they sink toward the rocky cores of these planets, where it is believed vast oceans of liquid diamonds might exist. Pause for a moment and picture it, not clouds tinged with gold at sunset, but entire storms of glitter, where lightning bolts flash against a backdrop of shimmering crystal rain. It is a scene so surreal that even the most extravagant dreams of treasure cannot compare. A single storm could create more diamonds than all the mines on Earth combined. Yet these jewels, perfect in form, are destined never to be worn, never to be set into crowns or rings. They are locked away in alien worlds, unreachable, belonging only to the vast mysteries of the cosmos. For scientists, this is not only a dazzling vision, but a clue into the chemistry and physics of distant planets. By studying how such rain forms, we learn about planetary formation, extreme conditions, and even hints of what lies beneath layers that human eyes will never see directly. These storms of diamonds are more than beauty. They are keys unlocking secrets about worlds so far beyond us, yet so strangely familiar. So when you gaze upon the night sky and see Neptune's faint blue glow, remember, beyond that tranquil color, a storm unlike any on Earth rages on. A rain of treasures falling endlessly, silently, forever. Not myths, not imagination, but the universe's way of showing us that reality itself can be stranger and far more beautiful than fiction. Picture holding a simple spoon in your hand, light, ordinary, almost weightless. Now imagine filling that spoon, not with sugar, not with soil, not with anything from Earth, but with the dense matter of a neutron star. In that instant, the spoon would no longer be ordinary. It would carry a weight so immense, so staggering, that the ground beneath you would collapse, crushing everything in its path. A single spoonful of neutron star material weighs billions upon billions of tons, heavier than mountains, heavier than anything we could ever comprehend. Neutron stars are the remnants of once mighty giants. When massive stars reach the end of their lives, they explode in cataclysmic supernovas, leaving behind cores so compact that atoms themselves are shattered. Electrons are forced into protons, creating neutrons, and what remains is a star made almost entirely of this densely packed material. To call it heavy is an understatement. It is density on a level so extreme it defies ordinary imagination. To put it into perspective, 1 teaspoon of neutron star matter would outweigh the entire human population combined many times over. T outweigh. MOUNT outweigh INS mountains, oceans, even entire nations. The gravitational pull of such an object is so powerful that if you were to stand just a few kilometers away, the very bones in your body would stretch and snap before you even had a chance to take a step. Time itself bends in the grip of such gravity, as though the universe slows down to acknowledge the might of this stellar corpse. Yet within this unimaginable intensity lies a haunting kind of beauty. Neutron stars can spin hundreds of times each second, sending out beams of energy like celestial lighthouses sweeping across the galaxy. They are tiny compared to ordinary stars, barely the size of a city, yet they pack the mass of our sun within their compact shells. Imagine the sun squeezed into something only a few miles wide. That is the reality of a neutron star, small, deadly, but astonishingly powerful. The very existence of such an object reminds us how fragile, and yet how extraordinary, the cosmos truly is. Out there in the darkness, stars collapse and reform into these cosmic titans, teaching us that even in death, the universe creates wonders. And as you think of that spoon again, something so ordinary in your hand, let it remind you that beyond our skies lies a scale of reality so vast, so extreme, that our greatest weights feel like feathers. Stand on a beach for a moment. Let the sand run through your fingers, countless grains slipping away, impossible to count. Each grain feels like the smallest unit of nature's abundance. Now imagine scooping up not just one handful, but all the sand on all the beaches of Earth, every shore, every desert dune, every hidden stretch of coast. Even then, with mountains of sand surrounding you, you would still not match the number of stars that fill our universe. There are more stars in the cosmos than there are grains of sand on every beach of our planet combined. It's almost unthinkable. The Milky Way alone, our home galaxy, holds more than 100 billion stars. And yet the Milky Way is just one among trillions of galaxies scattered across the universe, each glowing with its own ocean of light. When astronomers point powerful telescopes into what seems like empty darkness, they don't find emptiness. Instead, they uncover thousands of galaxies hidden within a patch of sky, no bigger than a grain of rice held at arm's length. Each galaxy, in turn, brims with billions of suns. Imagine what that means. For every single grain of sand you've ever seen on your shoes, on your towel, under your feet, there could be entire solar systems, planets, and perhaps even life orbiting around stars beyond our reach. The night sky, in its silent beauty, is not sparse at all. It is crowded with possibilities, bursting with untold worlds waiting to be discovered. And yet, what's even more staggering is the thought that most of those stars are unseen to us, their light traveling for billions of years before ever brushing against human eyes. Some stars we gaze at tonight may already be gone, their final flicker extinguished long ago, but their light still racing across the cosmos to remind us of their existence. Others are just beginning, newborn fires in distant galaxies, destined to shine long after our world has turned to dust. So the next time you feel small, look up. Remember that you are part of this infinite sea, this endless cosmic shore. Each grain of sand you touch is a metaphor, each star a reminder that the universe is not only vast, but overflowing with wonder. And though we may never count them all, the very act of trying connects us to the limitless beauty above, where the stars stretch farther than imagination itself. Imagine living on a world where the sun rises once, and by the time it sets, an entire year has already passed. This isn't science fiction, it's the strange reality of Venus, our neighboring planet. On Venus, one full rotation on its axis a day takes 243 Earth days. Yet its journey around the sun, its year, is only 225 Earth days. That means Venus experiences a year faster than it experiences a single day. Think about the strangeness of that. If you stood on the surface of Venus, time itself would feel distorted. You would wait months for a sunrise, then endure months of unrelenting daylight, followed by months of darkness. A single day, there would stretch across nearly 8 months of our lives on Earth. Nights wouldn't just be evenings, they'd feel like entire seasons. But that's not the only bizarre twist. Venus also spins backward. Unlike Earth, which rotates from west to east, Venus rotates from east to west. So if you were on the planet's surface, you would see the sun rise in the west and set in the east, a cosmic reversal of the rhythm we take for granted here on Earth. Layer on top of that its brutal environment, crushing pressure more than 90 times Earth's, and temperatures hot enough to melt lead. Clouds of sulfuric acid blanket its skies, reflecting sunlight back into space, making Venus one of the brightest objects we see from Earth. Yet beneath that gleaming beauty lies a world so extreme that a single minute there would test the limits of any spacecraft, let alone a human being. Still, Venus teaches us something profound about the diversity of planets. Time is not universal, it is relative. The simple rhythm of day and night that defines life on Earth is just one version of reality. Out in the cosmos, time bends and twists into forms that challenge our imagination. On Venus, a year can be shorter than a day. On other worlds, days can stretch for weeks or vanish completely. So as you watch the sun rise and set each day, remember somewhere out there, on a world not too far away, time runs to a completely different beat, a reminder that the universe doesn't play by the rules we know. High above our galaxy, more than 25,000 light years away, drifts a massive molecular cloud in the constellation Sagittarius. To the naked eye, it's invisible, hidden in the depths of space. But to astronomers armed with radio telescopes, this cloud revealed something almost whimsical. It contains a chemical called ethyl formate, the very molecule that gives raspberries their flavor, and rum its sweet, rich aroma. Pause for a moment and imagine that, a giant cloud stretching across 150 light years of space infused with the essence of raspberries and rum. If you could somehow scoop a sample of its molecules, your senses would be struck with something strangely familiar, a taste and scent we associate with indulgence here on Earth, yet born in heart of the cosmos. This isn't just a curiosity, it's a glimpse into the chemistry of creation. Clouds like this are stellar nurseries, places where new stars are born, where planets take shape from swirling dust and gas. The same molecules that flavor fruit and ferment drinks on Earth are drifting among the stars, woven into the building blocks of solar systems. It suggests that the universe is not alien in its essence, but profoundly connected. The chemistry that makes life flavorful and rich here is the same chemistry scattered across galaxies. But as beautiful as it sounds, this cloud is not hospitable. Temperatures plunge hundreds of degrees below zero, and radiation pulses through its vast expanse. You couldn't taste it or smell it directly. Our senses would fail long before we ever arrived. And yet, the fact that molecules carrying such familiar properties exist in such abundance tells us something extraordinary. The ingredients of life, of flavor, of sensation itself are universal. Imagine drifting through that cosmic mist, surrounded by molecules of sweetness, knowing that they are the same molecules that give meaning to your taste buds on Earth. The line between here and the stars blurs. Suddenly, the universe doesn't feel cold and distant, but intimate, as if the cosmos itself whispers reminders of home in every corner. So yes, out there in the depths of space, there is a cloud that smells of rum and tastes of raspberries. It is not just a scientific fact, it is a poetic truth, a reminder that the universe is not only vast and mysterious, but also strangely familiar, flavored with the essence of life itself.